Our next panel is on technology development, and this is the final panel for the day. Thanks everybody for sticking with us. It's pretty fun. All right, and at the end of this panel also, we're gonna open it up to everybody to jump in and have a chat. So starting off, again, we're gonna have Ken Carloni again. I've already introduced him. So Ken is with the U Creek Land Alliance, and he's been doing a lot of work in this area of technology development. So Ken, please go ahead and share your screen.
Yeah, so picking up where we left off from the morning session, kiln design, kiln operation, kiln testing. And these are graphics that we've seen before. Basic flame cap kiln operation, flames on the top, pushes the oxygen away. And so you get pyrolysis rather than combustion. Okay, so then kiln design considerations. There are great kilns out there. Kelpie's kiln I haven't had a chance to actually use it myself yet, but I understand the principle, and I know a lot of people are using it, and it's slowly becoming the industry standard away from the Oregon kilns, at least is my observation. But if you have a bit of a design bent and some skills, you can think about designing your own kilns, building your own kilns. Things to consider are materials. Are you buying brand new material, in which case you're going to get killed because steel has gone crazy over the last couple of years, as Kelpie can attest. Fabrication, how are you going to put it together? Are you going to screw it? You're going to rivet it? You're going to weld it? You're going to spot weld it? And then thinking about efficiency, double paneled kilns versus single paneled kilns. We don't know yet whether the efficiency of a single paneled kiln, which is certainly theoretically, the double paneled kiln should be more efficient, but we've not measured those yet. And then considering then portability, getting them out into the woods. And also Joe and Dan were talking earlier, and some other folks, Mark, about your decision is in the field is, are you going to move your kilns to the fuel, or are you going to move your fuel to the kilns? And when you're running along a road and you're only going out 50 feet, 100 feet or something like that, it's awesome. Just plop your kilns along the road. But if you're and I should say that not all of our ground is as sweet as the ground that we're working on right now. So we have been down in holes and we've been up on slopes. And so being able to capture that, I think it was Kelpie that coined this term, stranded carbon. There's a need for kilns that can be packed up into the woods. And so modularity of the kilns is important. And then scalability. Can you use, like Kelpie's kilns, panel kiln, you can put 3 panels together, 4 panels, 5 panels, depending on the amount of fuel and the amount of labor that you have to be able to load those kilns. So here's a range of kilns. Actually, Dave Komorowski, the fellow I mentioned earlier, is with the NRCS in the territories now in the Pacific. This is a kiln that I designed for folks on Guam who are swimming in 55-gallon drums. They're cheap, easy to get. And so we did an experiment. We just sawed the things in half, connected them into a little daisy chain there, and it worked great. I think this is one of maybe Gloria's design here, a Kontiki type kiln. This is the original Oregon kiln here. This is one of the big kilns we saw a slide earlier, I think from Kelpie's presentation, this very same slide, where these very large kilns now take us beyond the realm of human, of human scale, where we have to load with machines. And then Kelpie's kiln down here, and this modular kiln that I've been designing that is in beta right now. Mostly not because I don't think the design is mature. The design works great, but it's the fabrication part that I'm trying, given that steel is so expensive and I want to make this cheap enough to get into the hands of people who can use it, I need to bring the production costs down, which is why I've been experimenting with spot welding as opposed to rivets or screws. those sorts of things. And this is, again, designed specifically to go after that stranded carbon. We're up on a hill now that's probably 200 feet from the road. And so we were able to hump that kiln up there panel by panel, and you can see it's burning nice and clean. And it's a double paneled kiln too. Air comes in the bottom, comes out the top, very similar to the way Kelpie's works. So if you have salvage material around and you have some skills and some creativity, I would encourage you to experiment with making your own kilns. And here's something that came from a conversation that Kelpie and I and another fellow that was in one of our workshops discussed is, what's the ideal surface to volume ratio? If your kiln has too much surface and not enough volume, you're going to lose more to combustion, because there's going to be more of the fuel is going to be exposed to oxygen, right? And less of it is going to be deep down where that radiant heat is cooking it into biochar. On the other hand, if your surface is too small relative to your volume, you're either going to have to burn more of that material on the top to char the material on the bottom, or you're going to get unburned material on the bottom of the kiln. So this is not the result of experimentation. It's the result of expert opinion. But somewhere around, a third of the square foot or square meter area on the surface to 3 cubic feet or meters underneath it seems to be about the right ratio. Equipment, protective equipment. First of all, having a face shield when you're dealing with these kilns sometimes can really be important. I ruined a $250 pair of glasses my first day out experimenting because I got too close to the kiln, and I kept thinking there was something wrong with my eye all day because it was blurry, but it was actually my glasses. So being able to protect yourself with a face shield is good. Everybody recognizes these tools here, Pulaski, McLeod, a shovel, but these fire swatters are really useful, because when you get the inevitable little chunk of fuel that falls out of that kiln and the fire starts creeping away from the kiln, you just grab this thing, whop, and then go back to work. You don't have to go get water and put the thing out or be messing around with your shovel or your McLeod or something like that. So fire swatter is really handy to have when you're working the kiln. Of course, no synthetic clothing. A spark lands on your nice nylon mechanic gloves and you got napalm there and a nice blister. Hard hat, face shield, hearing protection if you're going to be using powered saws. Not so necessary if you're using cordless saws, as I discussed earlier. Leather gloves, and also a pair of welding gloves, just an inexpensive pair. Pick them up at Harbor Freight. So if you really have to mess with something, if you really have to get your hands in, or you got to tweak your kiln or something, you can be well protected. Loading and firing. There's 2 ways to protect the soil, and this is from some of our earliest work that we did at U Creek. You can lay a corduroy of logs across the bottom, and what will happen is it just won't, it will take longer than it will take the kiln to burn all the way through that wood at the bottom. And so you'll actually rake up, little twigs and green stuff underneath. What we tend to do more often is we'll cut green boughs or anything that's wet and green to put on the bottom of the kiln to protect it. I think I mentioned that a little bit earlier. Getting the flame cap going, then you get a nice flame cap engaged. You feed, especially paying attention to the edges and corners if you have them. Round kilns don't. But anytime as you start to see that material mound up in the middle and your flame starts to dissipate around the edges, that's when you really want to focus on the edges to load that kiln up to keep infiltration of oxygen coming down the sides of the kiln and creating more combustion than you want, because our goal here is pyrolysis, right? The heated wood in the absence of oxygen. And these kilns that we originally set up were kind of nice because you could take the, we didn't put the ends on until the kiln was about halfway filled. And that way we could walk a bunch of fuel in and get a nice tight pack and then put the end of the kiln on afterwards, and those work pretty well. Now you notice this kiln is loaded up with some pretty heavy material, and we've been having this discussion today. And so I want to kind of circle back to, what we've always called the 4-inch rule. You look in here, and this is the bigger stuff that comes out of a kiln that you load with really big material. Now, that material, there's nothing wrong with that stuff. It's charred on the outside, it's torrefied on the inside, which means the cellulose and lignin is still there, but all the volatile oils have been burned out of there. And this goes back again to what we were talking about. What size of char do you put on the soil? Well, when you think about a forest fire is producing very fine material. It's producing, 1-inch chunks. It's producing partly burned material. And all of those are going to work their way into the soil at different rates and have different ecological functions as they do. So the old ecological adage, diversity begets diversity. I believe that with biochar as well, is that having a less uniform product at the end, if you're not putting it in a bag and selling it or trying to do, something that requires a very uniform material, all of that diversity is good for the system. And I've got a pile of these set up to try some hugelkultur, which I think I've coined the term charcoal culture. I'm going to try to use these logs. Hugelkultur is using logs in your gardening. So you lay a bunch of logs down, you make a mound, and as the logs decompose, they hold water and promote plant growth. It's obviously by the umlaut there, that's a German, it was developed in Germany. But those logs, if you're not going to put them back on the soil, you can use them in hugelkultur. Lighting green fuel. Okay, everything that we've been doing since that first 6 acres, as I mentioned earlier, has been with green fuel. And now notice that here are Oregon kilns, right, loaded exactly the same way. And here my partner is sticking his torch right along the edge of the kiln. And the fire's burning underneath, and look at that massive cloud of smoke that's coming off there. Now that's going to be gone in 10 minutes, right? But why do that in the first place? If you light from the top, from the beginning, right, that fire burns down into the kiln, establishes that flame cap in just the same amount of time with far less smoke. So it's a minimal amount of extra smoke that you're producing, but why, if you can minimize the smoke, why not? So always light from the top, and then let it burn down so it has plenty of oxygen and it can burn that smoke up as it's being produced. Notice again, this is green fuel and it's burning very clean. Once you get that flame cap established, you can throw pure green stuff on there and you won't get a lot of smoke. Now, I'm going to talk a little bit more about potential gases coming off of that, and that could be a potential problem. So as you're loading, you stop feeding either when you fill the kiln, and I had lots of hands at this. This was a demonstration that I did, and there were 10 people loading this thing, so it was great. But about an hour before quitting time, stop loading the kiln so that you give the fuel a chance to bake into mostly biochar. You'll see ash on the top, and some of the wood will be kind of alligatored up. And then that's when you want to quench. And again, the beauty of these panel kilns is that you can open them up, rake them out, and hit the hot spots. And so an Oregon kiln takes about 50 gallons to quench. This kiln here, actually this is set up as a 6-panel. I just ran an 8-panel kiln, and it took us 50 gallons to quench that. So again, protect your soil from the beginning, either with a lot of heavy woody material, or much more easily with a bunch of green material. So as that water evaporates from that material, it cools the soil as it goes. Now, we did do some actual physical measurements, and thanks to Darren McAvoy for buying the scale for us. We were able to park our truck here, load it up, and then load the kiln with this, so we knew how much, what the weight of the fuel was going in. We used moisture meters to figure out the moisture and to subtract that. Our moisture in some cases was 30 to 50%. So it was full of moisture. And what we then did was we then took that char and took representative samples from the kilns, sent it down to control labs in Watsonville, California to do an analysis. And interestingly enough, the within kiln variation, when we sampled within the kilns, was quite high. And you can see the between kiln variation, we got 31.2% of the carbon in the feedstock was ultimately left over in the carbon in the char. And this one was 41%. So that's a really big difference. So we're going to have to run these, we're going to have to do lots of replications on these kilns to come up with a central tendency. So we can say, on average, our kilns are producing this amount of carbon per the amount of carbon in the feedstock. But again, the concern is with methane, right? Because we tend to think that, oh, you're going to build this big wet pile and it's going to be a big smoky burn pile, right? Well, you know, kilns don't do that. However, methane is clear, right? You can't see it. You can see the smoke, but you can't see the methane. So I've been working with Ryan Thompson at Mountain Air Engineering. He's got a probe that he's designed that can measure carbon dioxide, carbon monoxide, methane, the sulfur and nitrogen compounds, volatile organic carbons, oxygen, and then particle mass, so that we'll be able to see not only what our efficiency of our captured carbon is in terms of what's left over in the feedstock, but also look at the avoided emissions there. And both of those should allow us to come up with a formula to say, using these kilns, under these circumstances, using this methodology is going to give you an average amount of captured carbon of X and avoided emissions of Y, especially in the greenhouse gases. And that way, then if we can quantify that, that will allow us to tap into carbon markets that are already available and potential cryptocurrency like materials as well. So,
oh, good, you're wrapping up.
So that's the last slide.
Thank you, Ken. That's
Okay.
great. Thank you very much. If you'll unshare your screen, then our next panelist is Darren McAvoy, who you just mentioned. Darren's been a partner in our adventures here for a while. And Darren is an extension professor at Utah State University, assistant professor of forestry at Utah State University, and he chairs the Utah Biomass Resources Group. Darren was formerly a consulting forester in Sandpoint, Idaho, and he was also a wildland firefighter, crew boss, and prescribed fire ignition boss in Montana and Idaho. And he was a sawyer on the Flathead Hotshot crew during the 1988 Yellowstone fires. He's a fellow of the Society of American Foresters. At Utah State, Darren has initiated many innovative projects to develop biochar production technology and markets for biochar products. So we're really happy to have you join us today, Darren.
Thank you, Kelpie, for that kind introduction, and Ken for those mentions. My name is Darren McAvoy, Extension Assistant Professor. I want to talk to you today about big box biochar kilns. As Kelpie mentioned, I represent and chair the Utah Biomass Resources Group. Our partners are super important to us. I don't do anything without partners. Southern Rockies Fire Science Network, the Forest Service, the BLM, DNR, John's company, Go Biochar, is an important partner as well. Just wanted to share a slide or two to show you that I didn't just start off burning stuff in boxes. I started off actually with gasification, making biochar in 2009, the biomass group did. Then we moved on to pyrolysis and mobile pyrolysis. This is actually the machine that John owns now with Go Biochar at the time. This is in 2014. It was Amaron Energy's machine. But I came to learn that with that project we were doing from the last slide in the Nevada desert, it cost us as much to chip the wood as it did to pyrolyze the wood. And that didn't make a lot of sense to me. Also at the time, the price of bio oil had a big impact on our operations. And I was looking for a simpler and easier way to make biochar in the woods. And that's when I ran into Kelpie and at a conference up in Oregon and invited her down with a USU extension grant. And she brought 4 kilns and spent a day giving us our first workshop in Utah. We really appreciated it. It got us up and running. We had about 60 people, and I've been running with it ever since. And really like the Oregon kilns. We perhaps have a little different experience with them in Utah because things are so dry here. Here in this photo, we're working on aspen and Doug fir, and we find we can burn logs up to about 10-inch diameter. And we'll have a few bones left over afterwards, but almost all of it consumes or turns into a decent biochar. And so I was really interested in scaling this approach up. I was wondering if it was possible. Kelpie and I had a lot of conversations about that. She introduced me to the person who you've seen the big box, a couple of Ken and others have shown some slides of Brandon Barron's big box, and I went up there to Oregon and bought him lunch and found out what he knew about it and try to take it from there. And so I was able to get in 2019 a Utah Public Lands Initiative grant to get this going. And this is my first big box kiln. It's I call it the BB16 because it's 16 feet long and it's 8 feet wide. And this one is 6 feet tall, which turns out to be too tall. I think if you're in certain really heavy fuels, that might work well. But as you can see here, we're mostly burning juniper. This is where we got started, our first demonstration. I'm thankful to the Logan Ranger District of the Uinta Wasatch Cache for working with us, cooperating with us on this project. And you can see the piles that were in the background there on the right of the juniper piles that we're processing. And it's perhaps this kiln might be oversized for what we need for this material. And then with this size machine, this size kiln, a 3,000 pound kiln, it takes a really big track hoe to manage it. And it's really hard to manage it with just an F-150 to trailer it with a Tacoma or an F-150. I was really looking to scale back after this experience down a little bit to where I could have, instead of a 34,000 pound excavator like you see here with its own low boy and operator and scheduling problems, I wanted it just to be a mini X. And so discussions with Ken Carloni and others realized the value of a double wall construction. And so in 2020, built my first BB12, 12-foot long kiln, only 4 feet high. So much easier to look down into in light and such. And at 2,000 pounds, much easier to trailer with an F-150 or a standard pickup. That, as you've heard, the double wall helps protect the operators from the heat and creates more even heating and biochar production down within the kiln. I just want to point out the BLM has their own BB12, working with folks, grant proposals right now, folks from the Colorado State Forest Service and private landowners in Colorado to build one there. And the state, if we get a proposal, a grant proposal that we have put in, I think we're going to build another 8 for the 8 BB12s for the state. So sort of moving in the right direction. And here's a kiln loaded to the top, ready for top lighting. My colleague Will, top lighting, we tend to use just drip torches or propane torches for top lighting. And you've heard a lot about the flame cap, and didn't know if that would work well with this size of kiln, but it works great. It's all the same experiences pretty much that you've been hearing about as far as the flame cap goes. Once you get it formed, you might have a little puff of smoke once you add material, every time you add material, but then it quickly reforms. And just like all the other kilns, we keep adding fuels as the fire allows. It's like tending a campfire. You don't want to put on too much at once. And here we have a kiln just about ready to shift from flaming combustion to glowing combustion, which is the time we want to quench. And for us, I've found it's most practical. We tend to have 2 batches in the course of a day. We'll have a morning batch, quench at lunch, have evening, afternoon batch, and quench at the end of the day. Takes about 300 gallons to quench these kilns. And obviously this is more of a roadside operation. I'm on a landing here down in on the Heber Camas Ranger District. You went to Wasatch Cast, just outside of Park City. This is a salvage sale. They asked us, they want to just clean up whatever was left that the loggers and the firewood cutters would not take or did not take. And so that's what we're doing here. And perhaps a different experience, and you know, these are not open panel kilns, but my experience is that it's much more protective of the firefighters to quench within the kiln. It protects the soil a little bit more as well. This is at this one demo we were doing down in Moab. We poured it out, the char out of the kiln before we quenched, and just noticed that firefighters have a lot more exposure to the smoke and the heat when we do it that way. And I think we've all covered this, but I'll go through it again. It's somewhat my responsibility. We always build a fire line around it. We do see embers popping out of these. In June, I was doing a burn up just over the border in Idaho and dropped a log into actually an Oregon kiln. And just from that mechanical thud in there, it popped out an ember and landed on a cow pie. And it was actually during red flag warning. It was June 25th when we were doing this. So it made me pretty nervous. So just got to pay close attention to what you're doing. And I haven't heard anybody talk about cold trailing yet as a firefighter. That's a key skill. And that's where we touch every square inch with our bare hands of anything that's burned. And if I was on a fire and as a firefighter was assigned to say that this quarter-acre fire up in the mountains was actually out, I would touch every square inch of it with my bare hands before I would say that. And it's the same sort of thing. I take the same approach with char. We start with the back of your hand and use common sense. Don't just jam your hand into a burning pile of char, but do it slowly. But I won't walk away from a pile of char unless I can run my bare hands through pretty much every square inch of it and be comfortable, sleep well that night. Tipping these kilns with mini excavators is perhaps the trickiest part. It takes a skilled operator, and actually we've had just landowners and firefighters running the mini excavators, but the trickiest part is certainly tipping them, and probably the most dangerous part. Sometimes we'll use the chains, and sometimes we'll just grab onto the side of the kiln. It depends. It's a little better in this operation. He's pulling it uphill towards himself. Works a little better when we're pulling it downhill. And of course, doing it in kilns is much more labor intensive and more expensive than open pile burning. But here I'm doing it concurrently, and all that carbon on that just burn pile on the left is going into the air, and perhaps a third of the carbon in our kiln on the right is going to remain as carbon. During this process, I was asked to do a project up on the Heber Camas District that I mentioned, and they had not almost all, but mostly 30-inch diameter and plus logs. Here we're just seeing a lot of butt ends, and further down the hill is full-length logs, at least 10-foot logs anyway, from the leftover from the salvage, and were never taken. And I didn't know if the kilns would consume this kind of material, and it was no problem at all. Consumed it 100%. Didn't really have problem with bones or any that sort of thing. No more than usual. But it is true that more medium-sized material makes more biochar. But I see it as sort of a sliding scale between, are you more concerned with reducing hazardous fuels or making biochar, and how you operate the kilns, when you quench, that sort of thing. You can move that scale back and forth. One of the things I really lost a lot of sleep about going into this is, am I going to burn up excavators? Am I going to need to have a whole separate budget, and they're going to come back to me? But with a qualified or careful operator who's just feeling the machine every once in a while, we haven't had any problems with that. And we've done dozens of kiln burns now. We find one machine can operate several kilns, or at least a few kilns at a time. The bigger issue is you can't get them too far spread out. At first I would have a kiln here on this landing, this pile, and then I'd have a kiln a couple 100 yards away, and the excavator running back and forth, and the changed strategies. Now I just put all the kilns I have in one landing area if it's got a big pile, and we work there until it's done, and then move the kilns to the next site. It's important to note that a double wall kiln is much better for heating your burritos at lunchtime. You can balance them up there between that heat channel. And here we are, my partner from the Division of Forestry, Fire and State Lands, using his Tacoma to drag a kiln across this job to the next pile, and no problem at all doing this. It's kind of fun pulling a burning kiln like this. We have dog doors in them for draining, so we don't have a screw or any sort of system like that gets buggered up. These do get buggered up a little bit with just getting beat up over time, but I find that they're still operational. With a double wall kiln like this, it's a more durable dog door. So I want to point out that I have eyelets placed. At first, these ones on front I had right down on the ground, and it's really hard to get the clevises and straps through them, so I had them raised up a few inches. These ones on the side I use for tying the kiln down when we're transporting or for helping for tipping, and fork pockets so I can pick the whole thing up with a forklift. I do have stuffing lids for these kilns. I haven't really had a lot of luck, and I haven't really put a heck of a lot of effort into trying to snuff with them and pack mud into the edges and that sort of thing. We've been more of in a production mode. And so I've used them more as a kind of a safety device. If we need to walk away, if there's an emergency, somebody gets hurt, we have a fire escape, we can kind of shut the process down by putting the lids on, and we can walk away safely. I've mentioned the sliding scale between biochar production and fuel, hazardous fuel reduction. And this particular job, this landowner who's running the excavator is going to create a nursery here along the Colorado River in Moab. And so he was really interested in this biochar for nursery production. Just wanted to quickly point out, Utah has a long history of charcoal production. These are beehive kilns that are from sort of post-pioneer days, and wanted to compare them to this other little thing that I tripped across when I was fortunate to present on this material at the International Union of Forest Research Organizations in Brazil in 2019. And my colleague Hansu Pan from Northern Arizona University and I discovered that using these kinds of kilns in Brazil, they've reduced hazardous fuels. They don't call it hazardous fuels. They've processed more biomass in these kilns than exists in 1 year, than exists in all of California and all of Arizona right now. And I take that as a sort of a note of optimism that this hazardous fuel problem that we're facing as a national sort of crisis in some ways, there are simple ways that we can get a handle on that. This is my contact information. Thank you for your interest.
Darren, thank you very much. That is inspiring what you've done, truly.
Thank you. Thanks for all your help, Kelpie.
Yeah.
And Ken, I just wanted to also say, Ken, thank you for crediting me for buying you that scale, but I have to say it was USU and my grant money that actually did it.
Well, we've got some great collaborations going on here, and we've got 2 more speakers. And so I hope y'all will stick around, because these are some of the most important speakers of the day. And followed by, we're just going to open it up to everybody for a chat. So our next speaker is Raymond Baltar, Director and Board Member of the Sonoma Biochar Initiative, and also the Biochar Projects Manager for the Sonoma Ecology Center. He's also served as a consultant and project manager for groundbreaking biochar projects with the Redwood Forest Foundation, North Coast Resource Partnership, Department of Water Resources, CAL FIRE, and many private companies. With a solid background in visual communications and a master's in business administration from the Green MBA program at Dominican University, he's been a driving force in the development of the biochar industry in California and really in the world. I just want to say a few additional things about Raymond. He's one of those sort of seemingly quiet people who gets a heck of a lot done without a lot of fanfare. And so I really appreciate what he's done to advance this biochar in the woods concept, and it's been a lot. So, and he's done a lot else besides. So we're really lucky to have him here. Raymond, please take it away.
Well, thank you so much, Kelpie. I really appreciate that. That's, you know, there's just been so much work done in this area. It's been so wonderful to have to listen to all these speakers today. And it's just amazing how far this thing has come over this time period. So I'm going to talk about a few things having to do with permitting and insurance. I'll talk about a few other things as well. The permitting issue, now we're located in California, which many of you are in other areas that aren't quite so stringent, but we live in an area where the air districts and fire districts and everything else are just super stringent. So these are things that we've been thinking about and that we've had to deal with. So hang on here. So just a few of the things that we've done, Kelpie kind of was mentioning a few of the things, but we've, these are sort of some highlights that we've done over the last just couple years. We assisted Dan Falk, who's a wonderful forester, purchase the first tiger cat carbonator in the area. As Kelpie said, we received a North Coast Resource Partnership grant, which is how we got the money to purchase the 5 ring fire kilns and work with Karen, who's just been an awesome partner at the USAL Redwood Forest Company. And also we work with the Potter Valley Tribe on this same project, and that's just been really great. I won't go through the whole list, but we have a wide array of activities that we do. Some of it is, we're barely hanging on with this low little capacity that we have, but we're small, but we're mighty. So so we've been doing conservation burn and trainings with ag primarily with vineyards actually. We've done about 40 of them since 2013 when working with Peter Hurst and Kelpie as well. We sort of were pioneering this technique locally. We've branched it out, and now we've done many trainings up and down California, from Siskiyou County and Del Norte County all the way down to Riverside. And we've learned a lot about these techniques. So we've done not only ag, but we have been working in forestry as well. And there's a lot more interest in forestry now, which is fantastic in this. And we're getting calls almost every week for landowners and other people that are really interested in using these techniques. As is mentioned earlier by Karen, we did get this grant from the North Coast Resource Partnership. It was cap and trade dollars, and it was really an amazing project that we were so lucky to be able to work with the Redwood Forest Foundation on this project. And we really learned a lot from it, got a lot of good data, which has been published and is available in certain actually on the Redwood Forest Foundation website. So we have discovered, and this is kind of where we, once we started working with the kilns, we started to come up against some resistance to permitting, which we did actually in this Ruffy project. The local air district did not know what to do with it. Because they look like these, as far as their permitting went, that look like burn barrels, and burn barrels are illegal in California. And there was nothing in their regulations that, showed it was going to be, any different. So we actually got a very limited permit. And so that really started us thinking about, well, what, we really have to look at approaching the air district. So we also, I've had to make presentations in Siskiyou County and down in Riverside County now with the South Coast District, and up and down the coast in different air districts to get them interested and allow us to actually use the kilns. So a couple of years ago now, actually, we did a demonstration for the San Luis Obispo Air Quality Management District. We've done, I think, 3 different presentations for them now, and a really great guy named Andy Mutziger, who's in their planning department and who helped us arrange these. First, they started to be conservation burn trainings, and then also kilns. And he's been a real booster and really understands the whole biochar ecosystem and how important it is, but they're coming at it from the PM 2.5 particulate matter, particularly and other emissions viewpoint. And so we started working with him on developing an emissions proposal. It's a very elaborate proposal at this point. He's done a lot of the writing for us, which has been helpful, adapting it from what we have. But we're now working with the U.S. Forest Service Fire Lab in Missoula, Montana, who's going to be doing testing both in the field and at their lab with a lot of material. And we're also working with a guy named Jim Amonette, who's many of you already know, who's been going to be doing sort of some science-based work for us as well. So there's going to be two options. We're currently looking for funding for this. We thought perhaps the CAPCO, which is the Air District sort of high-level group, and I don't know if they're going to be interested or not, but we're now looking at a CAL FIRE grant, which is due soon on February 9th, where we're going to put together a proposal and hopefully get this permitted, funded. So this is going to involve 10 days of field testing with 19 replicates and 5 days of in-lab testing with 9 replicates. That's the first option. And then we're also going to, if we can get it funded, work with 2 different moisture levels so that we'll do, I think it was going to be 25% and 35% moisture to see what difference that is. So that'll bump us up to 10 days of lab testing and 18 replicates there. So it's very detailed, and there's a lot of good science that will come of it. And we're hoping this will be publicly available information. And I know Ken's working on that as well, which is fantastic. And so maybe we can kind of merge those 2 testings together and come up with a really, good rule of thumb that everybody can use for sort of assessing the amount of emissions that they're saving and the amount of carbon that is actually being saved. So we are going to measure the carbon before. We're working with vines primarily. It's kind of a very stable, sort of consistent sort of material. So we'll be able to kind of figure that out easier. We'll be using, measuring the moisture content of the vine. We're going to be measuring the weight and the volume of all the pile replicates. We're going to be measuring all the GHG, greenhouse gas, criteria pollutants, and particulate emissions from conservation burn piles, kilns, and a control. And we're going to be measuring the quantity and quality analysis of the biochar that's produced. And then Jim Amonette's going to be doing the life cycle analysis of the burns versus many alternative fates of the material, including chipping, lop and scatter, you name it, a bunch of different things. So we're hoping that this is going to be a pretty robust set of tests that will actually be able to show to the air districts. Now, this is something I didn't mention before, but there are 35 different air districts in California, and each of them has sort of different rules about burn permits and ag permits versus forestry permits, and the local CAL FIRE, permits are different. Or so we really were trying to get a set of data that we would actually be able to shop around to all the air districts and have them come up with a consistent sort of permitting for the kilns. The conservation burn piles do not need anything other than a regular burn permit, but we were getting some resistance, as I mentioned before, about the use of the kilns. So again, this is just kind of showing the fire lab up in Missoula and what they are able to measure. They have very sophisticated equipment, and then they're going to come down here into Sonoma County or Napa County, and we're going to be doing the field testing as shown below. And they have, again, they're very well respected fire lab. So in the interim, we have been trying to get permission from some of our local districts. In our case, it's the Bay Area Air Quality Management District in our area, but we've also been working with the South Coast Air District, and both of them are very stringent. And we have actually gotten rulings stating that the use of these portable kilns is exempt from any special permitting, and that as long as you follow the regular open burning rules for ag and forestry, then you don't need any kind of special permit. So we were really excited about that. That was very recently. And then we also got a similar ruling from the South Coast Air Quality Management District. And the reason we're looking there is we've been retained by a water district down there, the San Bernardino Municipal Water District, that's also interested in using these kilns, and we're going to be retained by them to do some training. And so we had to go through their air district as well, and we got another ruling. So we're really excited that we're now starting to get rulings stating, written rulings that we can actually get permitted to use this without kind of doing it under the table without really telling them about it. So so it's been kind of covered all along, but we just haven't actually had a good ruling. So now we only have 33 more districts to go. And it may not be the same issue in Oregon or in Montana or in Wyoming or other areas, but in California, not only do you have to deal with the air districts, but you have to deal with CAL FIRE. And as you all know, we've had massive fires here. So it's a big issue, not only from an emission standpoint, but also from fire safety. So we've also come up against insurance issues. And this is something else that I think, I don't know how many of you have really thought through this. I guess that if you're, working as a contractor and in the forest, you're going to have insurance about using fire. But here in California, there's been a lot of pushback about prescribed fire and issues about permitting prescribed fires, mainly because there's so many homes in the WUI, the wildland urban interface. And so our insurance company at the Ecology Center has started to balk at us and our crews doing kiln burns. And we're sort of negotiating with them right now, trying to come up with, showing them, we have safety manuals and we have safety protocols, and we use all the right equipment, et cetera. But they're still sort of balking at that. Our original goal with the North Coast Resource Partnership was to use the kilns for both the Potter Valley Tribe and USAL project, and then be able to lend them out to local fire safe councils and other landowners to be able to teach them how to process their own material and just charge a very low fee after we train them for the use of the kilns. But our insurance company will absolutely not allow us to do that. So if you're thinking about this, you need to make sure that you not only think about getting all the right permitting, but also what's your insurance impact. And are you doing this, above board, or are you just kind of doing this on the side? So anyway, it's really important that you think about these issues as well.
Raymond?
Yeah.
We're running behind.
Okay, I'm sorry. That's it. That's
Okay.
it. My last slide. So.
Oh, great. Oh, thank you so much. Yeah, that's
Yep.
that's a long discussion, and maybe we can get into insurance issues after we're done.
Sure. I'm sorry.
Thank you so much, Raymond. No, you were great. We're just in general running behind, and we have our last speaker is Jim Archuleta. So Jim, if you would share your screen. Jim is the Regional Wood Innovations Coordinator, Jim, for the U.S. Forest Service, and that would be in the Pacific Northwest region. Jim Archuleta grew up in Junction City, Kansas, in the Flint Hills area. He started his career as a district soil scientist on USDA Forest Service's Umpqua National Forest, where he became interested in using charcoal and biochar to improve the soil quality. This experience eventually evolved into a career in biomass and wood innovation, and ultimately to his current position as the Pacific Northwest Biomass and Wood Innovation Coordinator. Please welcome Jim Archuleta. Jim.
Yeah, so I'm Jim Archuleta, and as Kelpie pointed out, I work for the Forest Service and started out in soils and ended up in biomass and trying to take advantage of speeding through. Let's jump right into it. So I'm going to give you a couple examples of how we've identified some opportunities that we found as we've stumbled through some different practices and came to and actually used that information to expand on what we know about manufacturing biochar. So the first case is we have the 2009 Basket Ute helicopter landing, and the intent of this site was to create a permanent landing with a grass cover. This is a very deep pumice soil, so it's really nutrient poor, and it holds water poorly near the surface. The water that does go through the soil tends to be at the bottom of the pumice overburden. So it was also created or designed to reduce erosion control, because when you create a permanent landing like this, you create a lot of compaction. With compaction, you tend to have runoff. That runoff, as you can see, would have gone straight into a ditch line down to an adjacent road. And then the other opportunity that we were trying to promote was wildlife forage. And there's kind of a backstory about how I got into biochar. Was not because I wanted to increase soil organic matter. I had a wildlife biologist haranguing me about promoting wildlife forage. So what you can see here is the previous image showed that right here we had charcoal, over here we had some organic amendments, and over here was the control, no organics. And what you can see is in the control you have very sparse coverage. And then when you're looking at the organic amendment, which was an organic fertilizer, because there was no bonding sites associated with the pumice is glass. And so there's no places for the nutrients to bond to. However, when we look at the charcoal area, the burn pile charcoal, we see there's a significant amount of grass in comparison to the other two spots. Now, what we learned here is we built the pile wrong. We built this pile with a dozer, and in that process pushed up a lot of soil, and a lot of that soil covered and buried large pieces of organic matter that were cooked rather than burned. So it's what we have here is an example of a misstep, and in that misstep examination, we discovered the opportunity of biochar. So that also, at the same time, around 2009, we also were building a pile for our fast pyrolysis demonstration, which was on the same type of soil, approximately 5 miles away. And you can see here what we did was we laid down 3 large logs, and on those logs we built a corduroy deck. And then we built the pile right on top of it. We didn't build this to make biochar. We built it to elevate and dry the pile in anticipation of turning it into chips. However, after the demonstration was over and we walked away, some hunters got cold during the winter and burned it. So the next thing we realized was, there's a lot of charcoal sitting there. So then we started to realize what happened from elevating the pile when it was burned was you tended to have less, there was less direct contact with the soil. So as you can see here, there was some oxidation where there was a large piece of wood in contact with the soil. But over here where you see this boot scrape, there's not any soil alteration. There's no heat. There's no oxidation of soil minerals. So this soil is just, well, it's great. It's ready for the charcoal that sits above it now. So that's the other thing that we learned, was potentially how we build these piles. We may have an opportunity to maximize, or to not to maximize, but to create some measure of charcoal that can mitigate these kind of detrimental effects from the heat altering effects to the soil. So the other thing that we started to realize too was, as you saw in the previous photo, some of the logs, the larger logs, were not completely burned, and that goes to what Darren was talking about with the bones he was describing. You have some wood that, depending upon its size and how its interaction with the fire, it may not be completely burned. So we're starting to consider the idea that maybe if we had, a 4-inch diameter log or so, we could probably completely char it. And so by focusing on the less than 5-inch diameter wood, we could potentially have fully charred wood and no soil effects. Then this is also thinking about the hand piling. If you were to build that pile, you could maintain the structural integrity of that pile for a while. This is actually a picture of a pyre that's created when they have the winter festivals at my reservation at Taos. It's essentially just 2 pieces of firewood, kind of built like a hashtag pie tower. And then they throw some material in the bottom, the whole thing lights up. And as it off gases, you get these large flames. But after a while, the wood actually dies down, the flames die down, and the wood just stands erect as a pile of charcoal until the carbon in the charcoal starts to become consumed, and then it falls under its own weight. Nobody actually harvests it, but it's maybe it's an idea. And here's a picture of some folks that actually do harvest charcoal in this very same manner and use a very distinct size for their wood. This is a picture from that I got off the internet about how Jack Daniels makes its charcoal for alcohol filtering. So they use a 4x4 board, 4 inches by 4 inches, and it works really well. Just as I described previously, they're able to wait until that the wood is done off gassing, and then they knock it over and put out the coals with just a misting hose on the mist setting. And that's how they make a lot of charcoal for filtering the alcohol or other purposes that they may have, because now they're selling bulk charcoal and other things. So there's potential opportunity there, I think, if somebody were to figure out how to do some of this stuff. And like I said, this is all just kind of observations that have taken us to what we're doing now. So once again, assuming that if we have 4 to 6 inch wood, potentially we can fully char it and hope maybe manufacture or build enough of a pile to harvest it. So that brings us to what we're currently doing. And what we have here is the char boss that's being built by Air Burners Incorporated with the U.S. Forest Service. And as you can see inside this burn box, if you can kind of make it out, the wood actually is being shaken. So that agitation as the charcoal forms on the surface of the exterior surface of the wood, it's constantly rubbing against the next piece and falling off. In the bottom of that, there is a sieve. So as charcoal forms and falls into the bottom, the shaker allows it to fall through to the next layer. And as you can see, there's a steel belt that it falls onto, and that charcoal actually is extracted and falls into a water bath, so it can be immediately dumped out. these are the processes that we've kind of taken us from 2008 to present day with our current development that we're going through with Air Burners Incorporated. And hopefully we'll be able to start seeing some of that equipment. And I know Deb Dumrose with the Rocky Mountain Research Station is going to be seeing some of that equipment, hopefully in the near future. And in the essence, or in to speed things through, ready for questions.
Thank you, Jim. That's really exciting about the Char Boss and the work that you've done there. You know, it's pretty much your idea, correct? The Char Boss?
Yeah.
Good. Good work. And we can't wait to see those blanketing the landscape.
And Deb's on that too.
Okay.
Both Deb and I. So.
Awesome. So we have a couple of questions we'll take, and then we're going to kind of close this session, but if people want to stick around and have conversation, that'd be great. So let's see. For Raymond, Dave wants to know, has the Mendocino Air Quality Management District issued a ruling on kilns yet?
No, they haven't. But we haven't approached them with this new information that we got from Bay Area and South Coast. I think they will probably do that. So that's just one more thing. That's something we have to do to sort of convince them. It was difficult because that was in a COVID period as well. So we couldn't do a lot of presentations, early on. And since it was just really a 4-month kind of a thing with, anyway, that's something that's on our docket to do, but no, the answer is no.
Good. And then another question for you is, Peter wants to know, does anyone have apples to apples comparison between kiln and conservation burns on yield, emissions, time and motion, etc.? Is that anything you have a handle on, Raymond? Or
we are going to be getting some of that, not the time and motion. Somebody else has done that, I thought, somewhere along the line. Wasn't there somebody associated with you that did some of that?
The permaculture group is starting to do it.
Mm-hmm.
But yeah, that's work that has to be done.
We're definitely going to be getting the comparison data, though, between the amount that's actually produced in each of those techniques.
Okay. And then for Jim, when is the Char Boss going to be available for purchase? Evan wants to know.
Well, we're hoping that we'll be able to get something situated for a limited production run by maybe the end of this year or 2023. But that's not my decision. That's Air Burners.
Okay. And then Jerry says the videos I've seen of the air burner don't show much char coming out. What's the latest on this? So I guess that's, some estimate of the production efficiency of the.
Yeah, that's one of the things that we're working on right now. The unit is in Florida. The beta unit is in Florida, and it's been given to an operator, and they are just trying to wear out parts. So we want to be able to fix this thing they want to be able to fix this thing to the point where they can release it and it doesn't need to be repaired or large maintenance or repairs for 5 years. So they want to be able to get this thing as bulletproof as they can. And during that process, we're trying to come up with some of the throughput understandings.
Okay. And also Josh Kursky wants to know, is there an estimate of how much that Char Boss is going to cost?
I can tell you what they've told me is it's potentially under 75,000.
Mm-hmm. Okay.
Or in and around that area.
Good to know. Start saving your money, everybody.
And
Jerry,
if I could, the thing
Yeah.
that's really important about that is the primary purpose of that thing is for brush disposal. The secondary purpose is for biochar. So if you're working in brush disposal and want an extra output, that's the machine that's the type of machine that you want to consider.
good point. Jerry wants to know, is the Florida location, the one at the golf course? That's the video I have seen. I think he's talking about the Bandon video. Do you want to just describe what was happening in that video, since a lot of people have seen it?
Sure. The Bandon video was the same unit. That video that you saw just a moment ago was done the same week on the Umatilla National Forest. Earlier in the week, we were at the Bandon Golf Course, and we were consuming gorse. So there's a real difference in the feedstocks. The sizes are relatively small and fine. And for those of you who are concerned about embers, we actually got more embers on the golf course with the fine material than we did with the heavies in the forest, which was great because we were right next to, we were stuck between a wilderness and a wooey. So we didn't want to have anything escape.
Wow. All right. Let's see. Here's a kind of general question for everybody from Evan. Do different plant or wood types produce different quality of char? Pine versus oak versus chaparral, for example? Maybe Ken, you have an answer to that?
Well, I'm not super up on the literature, but just thinking about it, torrefied wood, when it's heated up to 350 or something, what you're doing is you're removing the resins from the wood and from the biomass. And that's really what makes up the difference between most species, right? Is not the cellulose and the lignin, although those ratios can change, but it's all the other material that's in there, all the other volatiles. And so once you move those volatiles out, when you actually produce biochar, it just, from a theoretical standpoint, unless it's contaminated, with heavy metals or something like that, the char should be pretty similar. I'm curious if anybody else has data out there, especially Deb, if she's still on, to get that difference.
Anybody else want to weigh in on that?
Yeah, this is Deb. We ran a whole bunch of different wood through the same machine at the same operating conditions. It's probably been 10 years, five or 6 years ago. And we did find some differences. And, things like Scotch broom had a really low pH after they had been pyrolyzed. Most of the wood, had pretty similar conditions, but there are a few exceptions. And so, it's always good to check, see what comes out of the other end of your pyrolysis work.
Yeah, I mean, just the density difference would make a different kind of char, right? And then here's a general question about what are the pros and cons of high-tech or wood chip gasifiers versus other approaches, air curtain burners, kilns, or conservation burn, structured piles. Some of you have done both of these, like Darren, you've experienced both kinds of production. Also Raymond, you got any comments on the pros and cons of high-tech versus the more simple approaches we're talking about?
Well, in my opinion, there's room for all of these. We need high-tech designer biochars and people like John Webster to make it, for companies and folks with money to do it. And we also need small Oregon kilns. They're so accessible and so much cheaper to buy. And in my opinion, we need big box kilns because we need to scale it up, and we need to do conservation burns because that's absolutely the cheapest way to go. It produces far less char. There was a question about a comparison between how much char conservation burning does compared to a kiln, and I don't have numbers, but it's hardly a comparison. The kiln, I would say, does 90% more easily. yeah, that's my take on that.
I want to jump in there and say, I think it depends a little bit, of course, on the feedstocks, in that I have made an incredible amount of char very efficiently with really small brush, especially when I put it on a couple of sheets of old roofing tin, just an open pile. It goes really fast like that, collapses, and it makes a lot of char, but it has to be like ½ inch or smaller. Really fine brush. So, you know, who knows what the real answer is, but definitely in almost every other case, I think you're absolutely right. The kilns will yield more char.
I'll just jump in real quick and say,
Yeah.
I definitely agree with Darren. I think we need it all. I think, you know, there's different applications in different situations. The higher tech machines that have much better emissions controls and all that, I think that, you know, we're looking at those more in the urban environments. That's where it's really critical to have, you know, really minimal emissions. And yet when you're out in the woods, it's not quite as important. So I think we need all of it.
Yeah, Kelpie, this is Jim. I'd also like to concur with both Darren and Raymond. We got more vegetation out there than we can handle. We need everybody on board. Point blank.
Well, I agree. And I also think that there are places where we can also use the energy generated. So for instance, you know, Biomass One, the 30 megawatt power plant in Medford, Oregon, is making a lot of biochar, and they're producing 30 megawatts of electricity. And it's all from biomass that's pretty nearby, you know, because it's expensive to chip and haul. And so it's a lot of it's from the city of Medford, the green waste, and from sawmill waste. So, you know, yeah, we've got a biochar answer for every problem. Just about. Let's see, I'm looking for some more questions here. From Evan, besides the char boss, are there any alternative mechanical pyrolysis units that are portable and currently available, such as the unit that Raymond has worked with in Mendocino? So I think that would be the Biochar Solutions unit. Raymond, would you like to talk about that one?
There's a lot of sort of machines that are sort of in various stages of R&D. There's virtually no off-the-shelf kind of units, or few of them. There, you know, it's a it's a brand new world. You know, it's changing all the time, and you know, I think that there's, you know, our experience is that, you know, there's still a lot of work that needs to be done in this space. And, you know, there are some mobile units out there. I'm, you know, really glad to see the Char Boss coming on there. You know, the Carbonator is a mobile. I wouldn't say it was, you know, easily movable, but it's, you know, movable, and it's, you know, at a much larger scale. And but, you know, something like the Biochar Solutions or the Arty machine, which we're working with now, and others are containerized, and, you know, they're developing. I guess that's what I'll say. And so it's interesting. We're really looking forward for more people getting into this space, and for these pioneering companies, you know, getting support, people purchasing them, and then they can, you know, do version 2.0, 3.0, and eventually we will get, you know, to where we want to get, which is having these wonderful mobile units that can be easily, you know, moved around, and you know, really highly efficient and very well made, robust units that are more stationary.
So Raymond, here's another question for you from Will. He says, someone in our area was told by air quality that a metal kiln could not be used because of, I guess, metal residue left in the biochar. Is that true, or is it a rural myth?
I have not heard that. It hasn't shown up in any testing that we've done. I don't know. Have you, Kelpie? Have you?
I've never run into that, but I'll tell you, I was doing a job with people that had a whole lot of lumber, old lumber that had nails in it, didn't have paint. I wouldn't have done it if it had paint, but it had nails. And at the end of the day, I was like, wow, that's a lot of metal. I wonder if we could have gotten zinc or too much iron or something, or some other metal in the char. And so we were working with Oregon State at the time, and they tested it for metals for us. And there was no concern. There wasn't really anything detectably different than any other char.
Yeah,
So
nothing has
Kelby?
shown up. I'm sorry, nothing's shown up in the testing we've done.
Okay.
I think the
Yeah,
larger
Kelby, I would
concern,
like to-
go ahead.
Well, I just wanted to point out that in our work with air burners, they're always concerned about parasitism of the metal. So there is some degradation of the metal that occurs. However, it's probably not measurable or meaningful.
Okay.
At one point, I did find one report on the zinc coated residential trash cans that some people use that you see on YouTube videos as identifying as being a contamination source for zinc. I guess
I've looked at zinc because, you know, the heat shield for my ring of fire kiln is galvanized to protect it from rusting. And it has to be really high temperature, like welding temperature, to actually to volatilize the zinc. And so as long as you're under, you know, 600 degrees Fahrenheit, it's not going to be a concern. You know, it's possible that using some of those, you know, galvanized feed troughs and so forth might get somewhere close to volatilizing.
it
but I
can't
don't think-
smell
not
good.
generally,
Yeah.
not generally.
Should-
It's really welding zinc that's the problem, not heating it up.
If
No.
if you use galvanized for the inner container, it certainly smells totally toxic.
Huh. I haven't noticed
I
that.
don't know if it is, but I would assume it is.
Yeah, I haven't noticed that really either, but maybe it's more in the very, very beginning, you know, before it sort of gets cured. I don't know.
It might not be the zinc, it might be some oil or something, a finishing oil.
Yes,
that's on the surface.
Just the first few times.
Yeah. So I don't think we're really exposing ourselves to zinc.
I think the issue there is more worker safety than it is, you know, contaminating the biochar. You know, in terms of, because there is some concern about, but I think you're right, Kelpie. I think it's welding temperatures that you know, where that, you know, gets aerosolized, and then, but it's really, I can't imagine that that it would even be measurable in the char. But I think it's more of an issue the first burn or two with your workers.
Yet another good reason to have N95 masks
Yeah.
for all of your crew, and, you know, definitely.
So I characterized our char from our kilns, our big box and small box kilns, and the kiln that John Webster has. And and the lab always looks for heavy metals, and they have never come up with anything significant. In one of the batches, we were from John's machine, we actually fed to sheep in a fully sanctioned study. And by the way, we did find a significant increase in weight gain in lambs when they had biochar available to them and a 2% amendment to their diet, but there was no heavy metal issues there.
All right. I'm looking for some more questions here. I was hoping to maybe open this up to more people, but I'm not seeing how to do that. Jim, I see a comment from you about biochar Dow kiln. Did you want to talk about those?
Oh, just pointing out that that's another option too. They're deployable, so they could be, dependent upon the remote setting. It could be an option.
Okay. And
My
then
understanding,
anything
one of
else?
the things that makes those kilns shine is their scrubbing system, and they have on top of each one, and they remove actually the methane, which is not very common.
They do
Okay.
take a very specialized kind of feedstock.
John Webster, I was really remiss in not making sure we introduced John Webster to everybody. John is with Go Biochar, And John has been doing our tech support for this and helping us moderate. And I see Carol Riley is here too. She's been moderating. She's works for the USBI on communications. John is really a volunteer at this point. So I'd like to thank both of them for helping make this day happen. You guys have been amazing. And John is, so we're at the end of the program now, but we will stick around to answer more questions. Anybody who wants to. And John says, if you raise your hand and you want to talk, he can unmute you. So anybody who actually wants to talk, raise your hand and let's hear from you.
Kelpie, I just wanted to say a few words about what
Sure.
a great audience we've had today. We've had nearly 100 people stay with us for most of the day, which is just amazing. So thank you so much for that. And on behalf of USBI and our sponsors, just a big thanks to all our speakers. And I think it merits them saying their names: Carlos Rodriguez Franco, Debbie Dumrose, Karen Youngblood, Kai Kaufman-Krull, Larry Schoenhaven, Ken Carloni, Joe Pongratz, Dan Hansen, Mark Vandermeer, Abby Kohlauer, Gloria Flora, Dylan Percival Maxwell, Darren McAvoy, Raymond Baltar, and Jim Archuleta. And I hope I've gotten everyone, except of course, the real star of today's program has been Kelpie Wilson. She's the one that's really pulled all of this together for this great, great day. Just wanted to remind everyone that there will be a link to a recording sent to you automatically of the webinar once it's ready. So in case you missed anything, you can always go back to the recording and pick it up. In the chat during the day, we've put in all kinds of information about how to get a directory listing on USBI, how to access the Learning Center on the USBI website, how to join the groups bio that we have for Biochar in the Woods. So, excuse me, please feel free to access those links as you see fit. So I'm going to turn the program back over to Kelpie and for more shop talk.
Thank you, Carol. Thanks so
Kelpie.
much.
This is Steve Fahir. Can I
Hi, Steve. Yes, Steve, please talk to us.
just want to put in, first of all, congratulations. I think it's been an excellent webinar, but I wanted to put in a pitch for next week's events in Butte County. We will have a half a day kind of presentation seminar session at Butte College, Chico area. And then we will have 3 days of field demos that we would love to have as many people as possible. Thank you.
Thank you, Steve, and thanks to all of our Chico Butte County partners for setting all that up. That's going to be a lot of fun. So if you're in the area or can get to Butte County, Chico, California, please join us. There's information on the USBI website about that. If you look on our blog, there's directions to get there, and you can register if you like, or you could just show up. All right, anybody else want to talk? Have a question, comment?
Actually, I was curious. I was sort of hoping this would come up, and that is the diameter of the material. And I know that that was an issue with Joe and Dan, and we've always sort of gone with the 4-inch rule, and that's why I put that slide up there. And they had issues with the NRCS folks saying, well, wait a minute, what about, what about all this 6-inch stuff? And then I was also looking at some of Darren's stuff, really big wood that he was charring. And in our part of the world, that big wood is an ecosystem resource, salamanders, and it accumulates nutrients when mycorrhizae reach up into it and all that stuff. And so I know there's some controversy about, what the cutoff should be. And I'm going to really advocate for 4 inches, because beyond that, it's not going to decompose, as quickly as the smaller diameter stuff. And larger diameter stuff, obviously, we're going to leave on the ground. But the whole 1,000-hour fuel idea, I know you talked to Andrew Owen with the NRCS here in Oregon, saying that, oh, well, with the environment changing, those 1,000-hour fuels dry out sooner and stuff. But I still would say that, I mean, the only operational reason to go up to 5 inches is because mills tend to buy, the smallest log they're going to buy has a 5-inch top. And so from an operational standpoint, I mean, there's a lot, there'd be a lot of 5-inch material out on a commercial logging venture. But since a lot of what we're doing is restoration work and taking out small stems, I would really, I'm an advocate for leaving everything above 4 inches out on the ground. And I'm just curious about what other people think about that.
Darren, you better weigh in here, I think.
Yeah, I don't disagree, Ken, from an ecosystem point of view. The slides that I showed of us doing that 30-inch diameter material, that's what we were asked to do by the Forest Service. They had already yarded all that material in a salvage harvest and had the firewood cutters had their way, and took what they wanted. And the district just wanted to get rid of the rest. We were just doing our job, but I don't disagree with your ecological point.
All right. And Jim had a comment in the chat about sudden oak death. Anybody want to say something about sudden oak death? I'll start.
So
There's a group called Sudden Oak Life that is using fire mimicry to eradicate that disease. But Jim, tell us about your project.
well, so it's not my project, but the ODF has identified the opportunity to use a burn boss potentially to go down into the sudden oak death area and sanitize the wood so that they can have a wood product for the first time since around, I believe, 2001. Since 2001, Southwestern Oregon has had a quarantine and prevented a lot of lumber and a lot of other forest products from coming out of that quarantined area. This would be a first.
Great. Peter Hurst wants to talk. Can somebody unmute him? John.
I think I'm unmuted now. Is that
There
right?
you are. Oh my God, Peter's unmuted.
Hi, Kelpie.
Hi.
On the question of particle size, we found when designing the atom retort that actually 9 inches was about the practical maximum that heat could be expected to penetrate in the cycle of that retort, which was about 6 hours. So I think 4 inches is a good maximum for ecological reasons. 5 inches would probably be practical for most operational reasons. There was a related question about how do you judge what size you should use. So let's assume we set a 4 or 5 inch maximum. The maximum diameter you can burn, that you can char effectively, we found, is directly proportional to the length of the burn you expect. So if you've got a huge pile, like some of the vineyard burns that Raymond and I used to do in Sonoma, that thing's going to burn for 3 or 4 hours easily, and that will go through a 4 or 5 inch log, if assuming everything else is equal. But if you're just doing very small hand piles or very short burns in kilns, you shouldn't expect to be able to go through 4 or 5 inch material in half an hour or 45 minutes.
Thanks, Peter. I just want to say a couple more things about Sudden Oak Life. This is a group in California. Their website is suddenoaklife.org. For those of you who don't know, sudden oak death is a disease. It's a Phytophthora, which is a water mold that is killing a lot of oak trees in California. It's probably because of fire suppression. And we've seen several studies showing that adding biochar to soils will really reduce the impact of that disease on trees. So they're a really interesting group. They're doing conservation burns. They have a ring of fire kiln, and they say what they do is tending the forest with fire. So that's a pretty neat thing if you want to check out Sudden Oak Life.
So is that what you meant when you used the term fire mimicry? They're doing biochar kilns and conservation burns, or is there something else to that?
I think they're also doing things where they're just physically removing moss and stuff that's, because the Phytophthora thrives in a wetter environment. I haven't looked into it a whole lot, but it's really something to look at. And there's a whole field that I was mentioning before, talking with Abby about prescribed fire, and then traditional ecological knowledge of fire and how to burn landscapes. And Ken knows a lot about this too, but I feel like that's what we need to go get back to, is relearning those indigenous knowledge practices about managing these landscapes with fire, because these landscapes, when Europeans showed up here, they were already a anthropogenic landscape. The native people here definitely managed the land specifically for their food and other resources, and it left this incredibly beautiful landscape that we have pretty well screwed up now. So there's a lot to learn. And I'm, next week in Chico, we're going to be going on Tuesday afternoon to the Big Chico Creek Ecological Reserve, and the ecologist there, Paul Maslin, has some really neat, very low impact techniques, which is almost, I'm kind of partial to the term now, fire herding, herding fire around the landscape. So he's making little piles and, lighting them top down. And then when they get down to the bottom, he'll scoop up a few coals and he'll take it to the next pile. So there's no fuel used for ignition. It's just one coal to the next. And then he'll take the rest of the coals, and this is in the winter time, he'll just fling them across the landscape with a shovel. The grass is wet, the ground is wet, and they're spread out, and it's, just a shovelful at a time, and the char goes out. And so it's very low tech. And it's kind of herding the fire around the landscape. You can do other techniques of line burning, where you put a line around a little brush patch and just light that off without even cutting the material. And then you could go through with maybe that fire swatter that you're talking about. Ken, I need to get one of those and put it out that way. So, there's just so much more we could do here to learn how to live with fire, manage fire, get the best we can out of fire. We don't really have a choice about living with fire. So
I'll just share this quick story. In 1988, when I was on the Flathead Hotshot crew, we were in southern Montana on a fire just outside of Bozeman in the Absaroka Beartooth Range. And it was only 3,000 acres. They told us to herd it up into the rocks, the fire. So this is how this term goes way back. And so we did. We were successful in herding that fire up into the rocks. And that was in June. Then it blew over the hill in July and burned up Creek City in August. And yeah, the story goes on. So just wanted to tie back that terminology.
Yeah. Well, I want to tell a story too about that. My friend Sean Hendricks, who's a base commander for Grayback Forestry, and he's helped me with a lot of my biochar projects. And he manages wildfire suppression efforts. And there was a fire on the Umpqua a couple of years ago, and it was it was approaching a ridge and was going to go down the other ridge. And there's a huge, tract of old growth, untouched forest. And there was a town below it. So the traditional hotshot approach would be to go right by the town and start a back burn up the hill to the ridge and just wipe out all that old growth to save the town. And he said, no, we're going to try different. And so he went up, in their helicopter, and he dropped ping pong balls just below the ridge on the other side where the fire was. So the fire went up, because fire will go up. toward a ridge, and they got the burn out there, not, you know, and saved, you know, a whole giant hillside full of old growth. So, you know, we just need to get a little smarter about this fire stuff.
That was the Stouts Creek fire, and that was a great story. I had heard that story.
Yeah. So anybody else want to talk? I see Rocky up here. Do you want to talk?
Sure.
Okay. What do you got
I
to
didn't
say?
want to. I had a couple of detail questions. I put it into the Q&A earlier, and I know there's a lot of people asking questions. I'm run a nonprofit, and I'm trying to help understand the trade-offs between the higher tech gasifiers. I'm interacting with All Power Labs, which makes a 20-foot container solution that they're going to deploy soon. And that's focused on biochar yield. And then there's CharBoss, which I learned about here for the first time. So that's really intriguing. And then there's the lower tech kilns and structured piles. I made up that term from what you guys are talking about. Maybe there's a better term. I'd like to better understand the trade-offs. Like CharBoss looks like it has the highest possible throughput, but I don't know necessarily what their yield is and what other trade-offs there are. If you don't need like combined heat and power or something, a CharBoss might be the most effective. You just put stuff in and any size still works. And a separate question, not to diffuse it too much, is I heard a couple of times protect the soil from a kiln, say, and yet a prescribed fire across the landscape, I thought one of the points is to apply heat to soil. Maybe it's a question of what temperature and how long, but I thought that was one of the benefits that the prescribed fire has that the other approaches don't have. They're not applying heat to soil. So if anyone can clarify the trade-offs, I'd appreciate that.
I'd like to jump in on your second part of your question about heating soil. Where the damage happens is when the charcoal burns. Flame usually goes through quickly, and so it doesn't have that sustained heating. So it's a matter of time and temperature, and you get the hottest temperature when the char is burning.
Some of the piles that I burned when I worked on the Flathead in the 80s, Deb Dumrose still uses those pictures as sort of a poster child of pile burning and soil damage. You still, to this day, 40 years later, you can Google Earth, you can see the holes in the vegetation where those piles were, because nothing has grown back. So a wildfire can do that in some instances if it's kind of slow and there's super heavy fuels, but it tends to move through a landscape a lot faster than just a pile burn. And piles, when they're machine piled, so the machine drives over the pile and compacts it, then they will tend to burn the soil a lot more. And when the soil is dry, it will tend to burn up a lot more.
Does anybody want to address the question of trade-offs between, I mean,
so
it really has to do with what your objectives are.
Yeah,
you know,
totally has to do with your objectives are, and these are all useful tools for different situations. And it depends on your situation. One of the trade-offs I see immediately is, you know, for higher tech machines, you tend to have to chip the wood before you put it in, which is a cost issue, but it's also a quality issue. You can't take a really dirty slash pile and chip it up and expect it to run well in a mobile rotary pyrolysis machine. So that's one of the trade-offs. And the cost of the machine, of course, is a huge trade-off. How finicky is it? Gasifiers are really finicky, really difficult. They take very highly qualified technicians all their time to keep the thing running. The one I had was from All Power Labs, and I bought it. I thought it would be practical for a rancher or a farmer to use this remote power for irrigation or something, but it took all the effort of the operator full time to keep, could never walk away from the thing, which made it unpractical. Those are a few thoughts, but I could go on and on forever probably.
Peter has his hand up, and then Walt.
Yeah, I would agree with respect to the APL unit. The PP30, which is their smaller unit, was proven to be very practical for continuous operation under some circumstances where you could pay attention to it. But the primary product of that was the power output. The trade-offs on what they're calling the char tainer or the combined char and power tainer are exactly as just described. With the right tending and the right tweaking, they can produce an incredibly high quality char. Austin Liu has been doing some incredible work with char produced at temperatures that 5 or 10 years ago we were just dismissing as being too much like activated carbon and not good charcoal. Turns out for a lot of applications that's not true. So they're producing chars at 800 C and on up to 10, 11, 1200 C that do amazing things, especially when co-composted. And I don't think that is easily obtainable without the controls that you get in a gasification unit. Again, it's very expensive, it's low yield, but super, super high quality for specialized applications such as co-composting.
Great.
And just to clarify, if I may, the char tainer is not yet a product. I mean, I'm not part of APL, I'm a researcher, and I'm working on exactly that co-compost pathway and trying to understand the trade-offs. Now that I'm learning about the char boss, I'm trying to understand the trade-offs between that approach and something like this high-tech gasification approach, which is still in R&D. My guess was that the temperature might be one of the defining characteristics. I'd love to know more about having to chip versus not having to chip. Darren, you spoke about that, but there wasn't any data. Maybe I'll follow up with you afterwards.
Great, thanks, Rocky. Walt has had his hand up for a while. Would you like to talk, Walt? You'll have to unmute yourself, I believe.
He is unmuted.
Okay.
How about go to Thomas and then come back to Walt?
Okay, Thomas, would you like to
Hello.
comment? Hi.
Yeah, the main thing I was trying to chime in at this point about, so I know Kelpie knows my background, but basically started out as a environmental scientist, a natural resource scientist, become a forester, and then shifted into hazardous materials. It was mentioned about the off-gassing. N95 is not an actual OSHA-approved mask for or barrier for that off-gassing. And so I put a NIOSH link in your information in your chat.
Okay. Thanks.
Basically, I'm an environmental safety engineer at this point.
Thank you for that. That's
Yes.
good to know.
What would you
Steve.
suggest?
Steve?
This is Walt.
Yes.
Can I?
Kelpie, let me just add
Just a second, Walt.
a closing comment is that all of this thing that we are learning and talked about today got to have a practical application. And speaking as a board member of the Fire Safety Council at Butte County and a Paradise resident who just recently moved back after the fire, we are fighting to remove all of the leftover biomass and even new biomass that we are cutting to clearing to protect the community. And even Kelpie's kiln is high tech. So we really have to be talking about making pile burning more efficient, more rigorous. We are working with contractors who never heard of biochar, and we're just getting to the point where our contractors who are clearing overgrown forest areas are required by our latest contract to do top-down burning of the piles. So that's progress. And what I'm saying is, on a practical matter, on a large scale, we have to stay low-tech and as practical as possible. Thank you.
Thank you, Steve. Walt, please.
Yeah, I think, am I audible now?
Yeah.
Thank you. So my application is to improve productivity of farmland, and I'm working with somebody who is thinking about buying a closed kiln from China to create like a ton a day of biochar from pine slash in Texas. And I would like to know if there's a real important difference between, or if there's any reason to prefer the closed kiln approach versus these, flame-based approach. So, it seems like there should be some chemical differences. You've talked about that a little bit, Kelpie, but I just wonder if do we know anything about how well those two different products serve for amending farm soil?
Well, a closed kiln, it could mean a lot of different things. There are a lot of different types of technologies out there. It's from China. I would say the first thing I would think about is permitting, because in Texas, maybe it's not as stringent as California, but in California, if you have a stationary source, you're going to have to jump through a lot of hoops. So that's just one consideration out of many.
That'll be lower consideration in Texas.
But still, without knowing what the actual technology is your question about the quality of the char or about the economics, or there's so many.
I'm curious about the quality of the char. So I'm actually I'm doing soil amendment experiments on my own farm and trying to understand how to, create an amendment that will hold nutrients for a long time. And if I need to pyrolyze things anaerobically, then I can do that. I mean, it's easy enough to do that, but well, it's not cheap, but it's possible. And if I can do it just in big open flame kilns like yours, then that's much easier. And if the product is equally effective, then I would rather, obviously much rather do that. But I don't really, it's hard, and it's hard to figure out anyway, because the feedstocks matter and there's all these other variables that matter. But just wondering if you take pine or you take mixed hardwoods and you pyrolyze them in an open flame kiln, or if you chip them and put them into a closed barrel with a hole in it and throw that in the fire, do you get comparable products?
I'll just comment, Walt. I don't know if you heard me say this earlier, but from higher tech kilns like what John Webster has with Go Biochar, you're going to come out with a 95% carbon, pure carbon rating from your biochar. And with the low tech kilns like the Big Box or Kelpie's kilns, the Oregon kilns, my experience is that you're going to come out with about an 85% pure carbon product. And so I don't know if that's helpful information to you or not.
So yeah,
the difference in cost is significant.
Yeah, it's so much cheaper to do it the way that I'm doing it.
The Big Box and Kelpie's kiln design they're super affordable and a great way to get started. Depending on your budget, maybe be practical about it. Start with one of these other types and see how it performs for you. Spend a little bit of money on the labs while you're perfecting your burn practices or your baking practices, however you want to look at it, and then decide if you need to upgrade, because a machine like I have is it's really expensive. But the advantage to a machine like I have is all computer controlled, time after time after time. Our batches are consistent.
Right.
But if you're only doing a ton a day, that's a small amount of biomass to be processing in a several $100,000 machine. So
another thing that I think Kelpie mentioned early on is that in the old fashioned buried char and stuff, of course they were using that for forages, and so all the extra leftover volatiles and tars and oils and stuff that are in there are great to burn, but they're not great for your soil because they're hydrophobic. And So the flame cap kilns will definitely give you 450 to 550 degrees Celsius burn, and that's kind of a in some of the literature anyway. It's kind of a sweet spot in terms of being able to not lose too much material from higher temperature burns, but still get the biochemical value in the soil of adsorbing nutrients and absorbing water and that sort of thing. So I think it depending on that system, if it's a closed system and those oils are going back into the char, it's probably not as good a soil amendment as it would be a forge, making char for a forge.
Yeah, those kilns usually off gas in some way, and usually the volatiles come back around and feed the firebox, whatever it is. So it's not usually, I don't expect they're usually putting the volatiles back into the char. But yeah, okay. Thank you.
Evan wants to know what machine you have, if you could just describe your machine.
Yeah, it's a rotary drum indirect fire pyrolyzer. It was made by a company called Amaron. They were getting into the pyrolyzer market. The owner has retired, so I acquired the machine in April. Prior to that, I was selling the biochar to the Utah regional market. So now I own it, and it's been a real unique journey. It's they take a while to get used to, so there's a learning curve.
All right. Well, a lot of good questions. Does anybody else want to say something? We're getting close to 5 o'clock here, and I think we're all probably ready to go have dinner or something. It's 8 o'clock in the East Coast.
6 o'clock here. Thank you very much, Kelpie. Thank you, speakers. Appreciate it, everybody.
We'll just sign off then. It's been a great discussion. Thanks for sticking around, and let's do it again.
Thank you, everyone.